So, welcome to Cheenta Statistics and Data Science. Today, we are going to solve this problem from IIT JAM MS year 2008. The problem is on your screen. It says that let x be a random variable such that expectation of mod x is less than infinity and probability x greater than equals half plus x is equals to probability x less than equals half minus x for all real numbers x, right? So, this notation, this expectation of mod x is less than infinity, just means that expectation of x exists. It just means that, nothing else. Now, we are asked to find out the expectation of x and the median of x among these four options, right? So first of all, you have to understand the concept of the following. A random variable x is said to be symmetric about a real number alpha if probability x greater than equals alpha plus x is equals to probability x less than equals alpha minus x for all real numbers x. This is important, this part is important for all real numbers x. Now you can easily see that the given problem is nothing but says that x is actually symmetric about the real number half, right? For alpha equals to half, we have this particular problem. So basically it says that x is a random variable which is symmetric about half. So now it is very interesting that if x is symmetric about a real number alpha, then its median is actually alpha. Why? See, since this particular equality is true for all x, therefore for x equals to 0, we have probability x greater than equals alpha is equals to probability x less than equals alpha. For x is equals to 0, right? This is true. For x is equals to 0. Now, what is a median? A real number m is a median of x if probability x less than equals m is at least half and probability x greater than equals m is also at least half. Is that such real number is called a median of x. Now we know that probability x less than equals alpha plus probability x greater than alpha is 1, right? It's true. It just means that now this part, we are just replacing this from this given condition. This part, we are just putting this condition. So probability x less than equals alpha becomes probability x greater than equals alpha, right? And the remaining is just the same, plus probability x greater than alpha equals to 1. Now, this can be written as probability x greater than equals alpha plus probability x greater than equals alpha minus probability x equals to alpha. This part is actually nothing but probability x greater than alpha, right? We just adjusted the factor of a probability x equals to alpha. Now, this part can be written as probability x greater than equals alpha is equals to half plus probability x equals to alpha divided by 2. Now, this part is obviously greater than equals 0, right? This part is 0, greater than equals 0, non-negative part. Therefore, this entire thing is at least half, right? Similarly, now probability x greater than equals alpha is nothing but probability x less than equals alpha from this condition, right? From this condition. Therefore, this is also greater than equals. So therefore, alpha is such a number that probability x greater than equals alpha is also at least half, and probability x less than equals alpha is also at least half. That means alpha is nothing but this, the median of x, right? Therefore, the median of x is alpha. This is true. Again, so we have found out that if x is symmetric about alpha, then median of x is alpha. Again, we claim that if expectation of x exists, then expectation of x is also equals to alpha. How to prove that? It's also quite easy. It's not difficult at all. Probability x greater than equals alpha plus x is equals to probability x less than equals alpha minus x for all real numbers x, right? It's given. It's, the definition of a symmetric random variable about a real number alpha. Now just taking alpha this side, we have probability x minus alpha greater than equals x, and taking x this side and the small x this side, we have probability alpha minus x is also greater than equals x for all real numbers x. This is also true. This statement just follows from the previous one, so this is also true for all real numbers x. Now what this means? Think about it. X minus alpha is a random variable, right? It's a random variable, and alpha minus x is also a random variable. Now, for all real numbers x, this part is true. This entire thing is true. What this means is that x minus alpha, this random variable, and alpha minus x, they are both identically distributed. X minus alpha is identically distributed to alpha minus x. This notation means that i- x minus alpha and alpha minus x are identically distributed. Now, since expectation of x exists, we already know that. That means expectation of x minus alpha is equals to expectation of alpha minus x, right? Same, because they are identically distributed and their expectations exist, so they have the same expectation. Now, expectation of x minus alpha equals to alpha minus expectation of x. From there, we can follow that expectation of x is alpha. That means we have just proved that if x is a random variable which is symmetric about a real number alpha, then its median is alpha, this part. And if expectation exists, this part is important. The existence of expectation has to be proved, first of all, or it has to be justified. Then expectation is also the that real number alpha. Now we already are in the light of knowledge that x is symmetric about half. Therefore, expectation of x is also half and median of x is also half. That means we are just the option is first option is true. Yes. Now you can also just use a very simple idea for this problem. This is the very subjective approach. You can also do it in a slightly different way, easier way in terms of if you are given just MCQ, you can take a very easy example of say no x follows uh, normal mu comma sigma square, right? If x follows normal mu comma sigma square, we know the graph of x, right? X is symmetrical about the real number mu, and we know that expectation of x exists and it is mu, and the median is also mu. So from this example, we can take an idea about a symmetric random variable about some number. If the expectation exists, the expectation is also the center of symmetry, and the median is also the center of symmetry. So you can also take that, but that does not constitute a formal proof. Obviously, it's just for MCQ purpose. So yeah, we are done. See you then.